Hello. In this video, we are covering two topics. First, adding an open-source C++ plugin to an Unreal project, the Newton Dynamics plugin. Second is a brief introduction on how to start using the plugin. There are a series of necessary steps for adding a source plugin to an Unreal project. Step 1. Creating the folder. Close Unreal and Visual Studio. In the File Explorer, navigate to your Unreal project directory and create an empty folder and name it Plugins. Step 2. Copying the source. Locate the Newton plugin folder on your system. It should be under subfolder /applications/toolsandwrappers/Newton Unreal/. In the Newton SDK directory, copy the Newton subdirectory into the Plugins folder you created in your Unreal project. Step 3. Regenerate the Visual Studio solution. Right-click on the Unreal Newton project file in your Unreal project directory. Select Create Visual Studio Project Files. This regenerates the Visual Studio solution with the newly added plugin. Step 4. Recompile the project. Double-click File Unreal Newton Project 1 SLN to open the new solution with Visual Studio. Verify that the Newton plugin is part of the project by browsing through the IDE Explorer. Select either the Debug Editor or Development Editor configuration. Click Build Solution to compile the project. This process may take several minutes. After compiling, press F5 to run the project. At this stage, your Unreal project is set up to utilize the Newton Physics library for simulations. Run the project to make sure is working as expected. We are now prepared for the second video objective, adding physics simulation to Unreal level. Step 1. Add a Newton World Actor. Newton is what in Unreal terms is called an application-level module. This means we do not have access to the internal structures of the engine. Therefore, the way the level and the physics library interface with each other is through intermediate glue objects that can communicate with both. Add a Newton World Actor to the scene. This actor manages global simulation properties, frame rate, multi-threading, auto-sleeping, etc. For now, we leave these options as default settings. Step 2. Creating a simulated object. In the Blueprint browser, create a new actor blueprint. Add a Newton rigid body component. Optionally, replace the default root component by dragging the rigid body component on top of the default component. Add one or more static mesh components as children. Each child mesh may or may not have a collision primitive. For this example, we select Newton sphere. Step 3. Setting rigid body properties and debug options. When designing a blueprint, we may want to have a visual feedback. Select the rigid body component and in the Newton category of Outliner panel, check Show Debug On. This will display all of the various debug functionality of a rigid body. Next, the Newton library uses the mass of a rigid body to determine its mobility. A mass value of 0 means static. In the Newton category again, find the mass property and set to 1 or any other value. These are the minimum settings to have a dynamics object ready for the scene. We are now ready to place any number of instances of this blueprint in the scene. Do not forget to click the Compile tab in Blueprint. Click the Run button. The ball will fall unblocked under the effect of gravity. This is because it is the only object in the scene. Step 4. Adding a background. Go back to the Blueprint browser and repeat the same process, but this time choose a box as Mesh and Collision Shape. Leave the mass option set to 0. This makes the object static. Also scale the box until more or less matches the floor box in the scene. Go back to the scene and place one instance of this blueprint, aligned with the visual floor as best as you can. The plugin has other shortcuts to turn static scenes into physics static background, but for now we follow the general way to make rigid body models. Run the simulation. Now the sphere should be blocked by the ground. We should now have a complete minimal physics simulation, and we can start playing with the object's properties, but we will cover that part in more detail in the next video. With this, we feel we completed our 2 goals. Thanks for watching.